All right, let's talk about data, but maybe not in the way you're used to. Today, we're going to look at it like architects. We're going to see how designing a database isn't some tedious technical chore, but it's actually a creative act. It's like drawing the blueprint for our entire digital world. So yeah, let's dive in.
So have you ever opened up a spreadsheet and just felt completely lost? You know the one I'm talking about. It's got duplicated names, data that doesn't match up, and trying to find one single reliable piece of information feels totally impossible. It's a digital haystack, and we've all been there. It's just data chaos.
And you can see that nightmare right here on the left. But look over on the right. That is the solution. It's a clean, organized plan, an entity relationship diagram, or ERD for short. That is our blueprint. And it's proof that before we can build anything useful or reliable, we have to have a solid design first.
And that's really the big idea here. Designing a database is exactly like an architect drawing up plans for a house. You have to decide where the rooms go, what they're for, and how they all connect, way before you even think about laying a single digital brick.
So, where do we start with any blueprint? Well, you start with the main structures, right? In the world of data design, we call these fundamental rooms entities. And they are the very first thing we're gonna draw. So what exactly is an entity? Well, think of it this way. An entity is just a key thing or a concept that we need to keep track of. If our database is a house, then the entities are the most important rooms. You know, the kitchen, the bedroom, the living room. They're the core pieces that the whole structure is built around. For this explainer, let's pretend we're building a simple database for a university. What are the most important things we need to track? Well, students obviously, courses, and lecturers. These three are our main entities, and on our blueprint, we're going to draw each one as a simple rectangle.
Okay, so we've got our main rooms, our entities laid out. But a blueprint with just a bunch of empty boxes isn't very helpful, is it? Nope. Now we've got to add the details. We need to describe what's actually inside each of those rooms.
And these details, we call them attributes. An attribute is just a property that describes an entity. So if the entity is our room, the attributes are all its features, like the color of the walls, the size of the windows, maybe the type of door. They're the specific little bits of info that give our entities real meaning. So how do you find these attributes? It's actually pretty intuitive. You just pick an entity, like our student, and you ask yourself, what do we really need to know about a student? Well, we'll definitely need a unique student ID, their first and last name, and probably what course they're taking. On the blueprint, we just draw these as little ovals connected to the main entity rectangle. It's as simple as that.
So if we do this for our whole university, we can see a student has an ID, a name, and a course. A course has a code and a title, and a lecturer has their own ID and a name. See how our blueprint is already starting to get a lot more detailed and way more useful?
Okay, so we've got our rooms, and we've got all the details for each room. But, a building is not just a random pile of rooms. It's the connections, the hallways, the doorways that make it a place you can actually live in. And the exact same thing is true for our data.
In the database world, these connections are called relationships. A relationship simply defines how two or more of our entities are linked. It's that hallway connecting the bedroom to the kitchen. It is the absolute crucial link that shows how all these different pieces of our data actually relate to one another. I mean, let's just ask a simple question. We have lecturers and we have courses. How do they connect in the real world? A lecturer doesn't just exist in a vacuum next to a course. There's an action there, right? A lecturer teaches a course. That word, teaches, that's our relationship.
And this brings us to the rules of these connections. There's a fancy word for it, cardinality, but it's really just common sense. For example, a one-to-many relationship just means one lecturer can teach many courses. Makes total sense. A many-to-many relationship means many students can sign up for many courses, and a course can have many students. This is how we build the real-world rules right into our design.
All right, we have gathered all of our pieces. We've got our rooms, which are the entities. We've got our details, the attributes, and we have our connections, the relationships. Now it's time for the fun part. Let's assemble them all and see the final, complete data blueprint. So, first things first, we start with the foundation. We just place our core entities right there on the canvas: student, course, and lecturer. These are the main structures, the pillars of our whole university system.
Next up, we add that layer of detail by attaching all the attributes. We're filling in the essential info that makes each of these entities distinct and actually useful. The plan is really starting to take shape now.
And here we go. The final step. We draw the lines and the little diamond shapes that represent the relationships, tying everything together. A lecturer teaches a course. A student enrolls in a course. And just like that, it's not a random collection of parts anymore, it's a complete, interconnected system. That right there, that's our blueprint.
You know, this diagram is so much more than just a drawing. It's like a universal language. It's what translates a business idea into a powerful, reliable database that can run an app, a website, or an entire company. This is the big payoff for doing good design work up front.
And that's really what it's all about. So the next time you're using an app to book a flight, or order some food, or stream a movie, just pause for a second. Try to imagine the blueprint that's running underneath it all. Because now that you can read the blueprint, what hidden digital structures will you start to see all around you? Thanks for watching.